Now let's talk about how to multiply fractions. Let me give you an example. Let's say I want to multiply a fraction 2/3 by a fraction 1/5. Well, multiplication operation is the easiest when you work with fractions, because the rule goes like that. You just need to multiply numerators together and you need to multiply the denominators together. So in other words, you need to multiply 2 by 1 and then 3 by 5. So those two you have to multiply, and the top numbers you have to multiply. So it's 2 times 1 is 2, 3 times 5 is 15. When you obtain the final answer, you want to make sure that it's in the lowest terms. So if it's not, you want to simplify it. Now, if we look at 2/15, we can see that nothing divides, well, except 1. Nothing divides 2 and 15 at the same time, right? So it means that this fraction is in the simplest form, and we can box that as the final answer. But I want to point out something. So I didn't have to get to the final answer to know that the answer is not going to be simplified. I actually could see that from the very beginning. So when I look at the numbers from the original fractions, I can see that numerators of the original fractions cannot be simplified with any denominators of the fractions. And by the way, I don't even have to check only within the fraction, within each fraction. I can kind of mix them up. And the reason I can mix them up because eventually they all get into one fraction anyway. So we'll see that in the next example. But when we say simplify, it's better not to wait until the final answer, but rather check if you can simplify from the very beginning. So I'm going to say simplify if possible. Like here, it was not possible before multiplying. Here's an example of how that happens. So next example, we have to multiply 6/7 by 4/9. So when I look at those two fractions, I can see that there's one number in the numerator that can be simplified with one number in the denominator. And the numbers I'm talking about are 6 and 9. Again, they don't have to belong to the same fraction because I will multiply them in the next step anyway. So I can pick one numerator from one fraction and then denominator from a different fraction. And the reason I circle them because 6 and 9, they both can be divided by 3, right? So I can divide by 3. And if I found that, then I'm going to go ahead and divide, and that's how I will write down the result. So 6 divided by 3 gives me 2, and what I'll do, I will cross out the original number and write down the result. 9 divided by 3 is 3. I cross out the original number and I write down the answer for the division. And once I simplified everything I could, then I go ahead and multiply, following the rule that the top numbers have to be multiplied and the bottom numbers have to be multiplied. Now I'm using the updated numbers, right, after the ones I got after simplification. So in other words, it's 2 times 4, which is 8. Well, I'll write it 2 times 4, and then 7 times 3. So it's 8 over, and then 7 times 3 is 21. And now, since I simplified everything I could before multiplying, I know that my final answer is in the lowest term, but it's still a good idea to double check in the case you miss something. But yeah, 8 and 21 cannot be simplified any further, so that's going to be a final answer. And let's do another one. So let's say 3/8 times 4/15. Okay, so before I multiply, I'm going to simplify. What can be simplified here? Well, it looks like 3 and 15 could be simplified. We can divide out 3, meaning that we can divide both of them by 3. 3 divided by 3 gives me 1. 15 divided by 3 gives me 5, right? Anything else? Well, yes, 4 and 8 can be simplified. both can be divided by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And after I simplified everything I could, now I'm going to multiply. So I'm multiplying across 1 times 1 in the numerator. By the way, this step you can skip. I'm writing it just for illustrating the process, but you can skip that step. And then 2 times 5. So you can jump right into this final step. 1 over 10. As we can see, yeah, it's in lowest term, so it cannot be simplified. And then finally, our last example for multiplication is going to look like this. We'll need to multiply 8, which is a whole number, by a fraction 7/10. Okay, so how do we multiply a whole number by a fraction? It's actually pretty easy, because what we need to do, we need to rewrite this whole number as a fraction. And this is how you do it. The whole number can be written as a fraction if you put it over the denominator 1. So instead of 8, I'm going to put 8 over 1. So I'll say rewrite. Now, why is that true? Why can't we do that? Well, remember, fraction bar represents division. So what happens when you divide 8 by 1? Well, you get 8. So now we can see how they are equal. And that's how you can do with any whole number. Just put it over 1 and it becomes a fraction. Times 7/10. So once you write as a fraction, then you just follow all the steps. Simplify first anything that you can. In this case, 8 and 10 can be divided by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. And I will be multiplying 4 by 7, that's 28. And then 1 by 5, that's 5. Now, this is a special kind of fraction. It's called improper fraction. For now, I'm going to just leave it like that in this fraction form. 28 over 5. Let's talk about how to divide fractions. Before we look at the actual division problem, we need to learn about reciprocals. I'm going to use these 3 examples to explain what reciprocals are. Reciprocal is such a number so that when you multiply the original number by its reciprocal, you always get 1. Product of a number and its reciprocal is always 1. I'll make this note. Product of a number and its reciprocal is 1. So by what do we need to multiply 4 over 5 so that we get 1 as the result? Well, it's actually will be that pretty easy to remember. If I have fraction 4 over 5, I need to multiply it by fraction 5 over 4 to get 1. So let's check. 4 over 5 times 5 over 4. Remember, before we multiply, we want to simplify as much as we can. So 4 and 4 can be both divided by 4. I'll get 1 in each case. And then 5 and 5 can be divided by 5, and I'll get 1 in each case. And then once I multiply, 1 times 1, it's 1. And then 1 times 1, again 1. That is 1, right? Worked. And that's how we can always think about a reciprocal. So you just take the original fraction and put it upside down, in other words. So 1 over 7, its reciprocal is 7 over 1, which is actually the same as 7, right? And 1 over 7 times 7 over 1. Here, 7 and 7 can be simplified, divided by 7. So 1 over 1, that's 1, right? And then finally, how about if we have a whole number? How do we put that upside down? Well, before we find its reciprocal, which is just literally flipping the number, we want to write it as a fraction. To write 8 as the fraction, we just put it over 1. It's same as 8 over 1. And as soon as we see 8 as 8 over 1, then it's easy to figure out what reciprocal is going to look like. It's going to be 1 over 8. So 8 times 1 over 8, it's same as 8 over 1 times 1 over 8. And that is 1. Okay, so that's how you obtain reciprocals. Pretty easy. And now Let's look at the example where you need to divide fractions. So here's an example. 4 over 3, we need to divide by 4 over 5. Now, when you perform division of fractions, you have to remember two things. The first thing is, so there will be two changes to the original problem. There are two changes. The first change, the first one is, so I'm rewriting the first fraction, is to change division operation to multiplication. So change to multiplication. And then second, you take reciprocal of the second fraction. So instead of 4 over 5, I'm going to put 5 over 4. Now, once you perform those two changes, then you end up with multiplication operation, which we already know how to do, right? So then from there, you just go ahead and multiply, following all the rules for multiplication. To multiply, first I want to simplify as much as I can. It looks like 4 and 4. Those two can be simplified. I can divide both by 4. Get 1 and 1. And then multiply across. 1 times 5, that's 5. And then 3 times 1, that's 3. That is improper fraction, but we'll keep it as an improper fraction for now. So a couple notes. What you had to do is to change division to multiplication. And then second, write the reciprocal of the second fraction. Let's try another example, just for the practice. Let's see a set of examples. A. Let's say we have 5 over 6 that we need to divide by 7 over 12. Well, that's division operation, so I have to make those two changes, right? I have to, well, first fraction I keep, but then division I change to multiplication. Here it is. And then I'm taking reciprocal of this fraction, which means that I'll have to write 12 over 7. And then multiplying. I think, okay, 6 and 12 can be simplified, right? 6 I can divide by 6 and I get 1. 12, if I divide by 6, I'll get 2. So I will end up multiplying 5 times 2. That is 10. And then 1 times 7, that's 7. That's the answer. And the last example will be the following. I'll need to divide 4 over 5 by 6. What if I have to divide by a whole number? Well, not much that will change. So I have to keep the first fraction as it is, then division changes to multiplication, and now I have to take reciprocal of 6. We already practiced taking reciprocals of whole numbers, but I'll remind you to see how to flip the number. Write it as a fraction. So to write 6 as a fraction, I just have to put it over 1, right? That like that. And once I can see that it's 6 over 1, then its reciprocal will be 1 over 6 times 1 over 6. And now I'll go ahead and multiply. I can see that 4 and 6 can be simplified here, so I can divide both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So that gives me 2 times 1 is 2, and then 5 times 3, that's 15. That will be the answer.